Okay, we're going to switch up here to section 4.8. I know it's a jump now. We were in 3.4, but it still involves solving equations. But now what we're going to be doing is taking into account that we are going to possibly be looking at fractions within our equations. We've carefully avoided these. So the main idea here is that anytime you see fractions in an equation, what we can do is what's called clearing the fractions. Okay, so that's the main idea here. We want to clear our fractions. And what that means is we are going to first find a least common denominator. I'll explain what that is in a second. Okay, we're going to find the least common denominator first. And then what we're going to do is we're going to multiply both sides of the equation. Of the equation by the least common denominator, which we will call the LCD. So least common denominator from now on, when you hear me say LCD, that's what I'm talking about. Okay, so let's take a look at this first example. All right, so we definitely have some fractions here. I want to point out that x is the same as x over 1. So if we look at all of these denominators, 1, 6, and 2, let me list those out. We take the numbers 1, 6, and 2, and we think about all the different multiples of these numbers. So, of course, let's start with 6. You could have 6, 12, 18. So basically what I'm doing is 6 is 6 times 1, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, and so on and so forth. Then all the multiples of 2, 2, 4, 6, 8, 10, and then all the multiples of 1, well, basically the multiples of 1 are 1, 2, 3, 4, 5, all numbers, right? So what you're trying to do is look at these three numbers and find the least common multiple, which we will call the least common denominator. So notice what number appears in all of these lists. 6, and then 6 was here also in 6. So the least common denominator for all of those numbers, or the least common denominator for this equation, will be the number 6. So what I'm going to do is I'm going to multiply 6 on the left-hand side of the original equation, which was x plus 1/6. And then on the right-hand side of the equation, I had a 1/2, but I'm going to multiply that by 6 also. So what I'm doing is I'm taking the original equation, which is this, equals 1/2, and I'm multiplying both sides by that LCD. Now, notice on the left-hand side I put parentheses. I did that because we have two terms. We have x term, and then we have this 1/6. Anytime you have multiple terms, you have to put a parenthesis so that that number we're going to multiply will distribute through to both. On the right-hand side, all we had was 1/2, and we only had one term, so I can just slap the 6 right in front of it. Okay, so let's go ahead and distribute this through. 6 times x is 6x, plus, now what is 6 times 1/6? Well, that's the same as 6 over 1 times 1/6. Because 6 is 6 over 1, and then the 6's go away and you just get 1. So when we distribute that second time, we just get a 1, and then we have to do 6 times 1/2. So 6 times 1/2 is the same as 6 over 1 times 1 over 2, and we can multiply straight across. We get 6 over 2, which equals 3. So the right hand side becomes 3. So now look at this new equation. We no longer have fractions, and that's the whole point of this technique called clearing fractions. We do something so that we're going to have a new problem to work that has no fractions in it, and those are easier to work with. But to do that, we have to find the least common denominator and then multiply both sides of the equation by that. So now that we're here, we can just continue. We can just do what we did earlier. Let's try and get the 6x by itself. So we'll subtract 1, subtract 1. We'll get 6x on this side equals 2. And then let's divide both sides by 6. So divide by 6, divide by 6. 6's go away, we get x. But notice our answer here. It's not a nice clean number. It's actually a fraction that we can reduce. 2 goes into both of those. 2 goes into 2 once, and 2 goes into 6 3 times. So our answer is actually 1/3. Interesting. Very different than what we've done before. Okay, let's look at this next problem. So we have a fraction. I think I can get rid of all this. Don't think we need that. Okay, so looking at the denominators of that equation, we have two numbers. We have the number 8 and we have the number 16. So the multiples of 8 are 8, 16, 24, we keep going, and 16, 32, and we keep going there, but we notice pretty quickly that 16 is the smallest number that appears in both lists. So what I'm going to do is I'm going to take the original equation, multiply both sides by 16. So 16 times negative 5/8 w equals 16 times 15 over 16. Now notice I did not use any parentheses. Again, it's because I have a single term on the left and a single term on the right. I only use parentheses when I have more than one term. So I can just multiply this. Keep in mind that 16 is the same as 16 over 1. That'll make the multiplication a little easier here. So when I multiply these two together, the w is just going to come along. I just need to figure out what this times this is. So I could do 16 times negative 5, but it would probably be easier if we reduce this first. We know 8 goes into 8 once, 8 goes into 16 twice. So really we're looking at 2 over 1 times negative 5 over 1, like that. And then we multiply straight across, we just get negative 10w. And then the right-hand side I hadn't done yet, but notice again, the 16s, those just cancel, and all we're left with is 15. So we have negative 10w equals 15. We are ready to divide both sides by negative 10 to get it out of there. Just leave us with the w. Those go away. We are left with w equals, and then this fraction reduces. 5 goes into 15 3 times, and 5 goes into negative 10 negative 2 times. So our answer is 3 over negative 2, or you could write that as negative 3 over 2. We talked about how it doesn't matter where the negative is, or you put the negative out in front of the fraction. So all three of those answers would be correct. Okay, let's take a look at this one. All right, so what are our denominators? We have 5, 5, 2. So if we think of a list, we only have to write 5 once. We don't have to write it both times. And then 2. Multiples of 5 are 5, 10, 15, 20. Keep going. 2, 4, 6, 8, 10. Ah, right there. There it is. I have an LCD of 10. So I'm going to multiply both sides of this equation by 10. Now notice I have two terms on the left. So when I do this 10, I'm going to do parentheses, negative 1/5 p minus 2/5, close the parenthesis, equals, now I'm going to multiply the right side by 10 times negative 1/2. Okay, I'll also remember that 10 is 10 over 1, 10 over 1, and on the left side we have to distribute. Let's go ahead and do the right side first. Here you get negative 10 over 2, which is the same as negative 5, so I'll write that right here. Let's distribute on the left. So when we multiply here to here, we have to do just the 10 over 1 times the negative 1 over 5. This is negative 10 over 5, and this is negative 2. So we're going to get negative 2, p, don't forget the p, and then here to here, we're going to do 10 over 1 times negative 2 over 5, which is negative 20 over 5, which is negative 4. So we get negative 4 there, or minus 4. And let me just write that next line down right here. And now we're back to a nice equation with no fractions. So I'm going to isolate the 2p by adding 4 to both sides. We get negative 2p equals negative 1. And finally, divide both sides by negative 2 to get the p by itself. So p should equal. Now we do have a negative over negative here, which is positive, but we can't do anything with that fraction. It's just going to be 1/2. So p is 1/2. Okay, I'm going to just skip through all that. Don't worry about that. So here's another example. Is that the one we just did? Yeah, that's the one we just did. So we won't do that again. Okay, here's a problem for you to try and work. I'll give you a moment to pause that if you'd like. Okay, now let me work it. So let's look at our denominators. We've got a lot of them. 3, 5, 15, 3. So we'll just list out those numbers. 3, 5, 15. I don't have to write 3 twice. So what is all the multiples of this? 3, 6, 9, 12, 15. I'm going to stop there. 5, 10, 15, 15, 30. I can keep going. But you can see here the smallest number that appears in all of these lists is the number 15. So I'm going to multiply 15 times the left side, and notice on the left side I have 2 terms, right? So I need parentheses, x over 3 plus 3 over 5 equals, and then I also have 2 terms on the right hand side, so I'm going to have to do 15 and then parentheses, x over 15 plus 1 over 3. And now I distribute through. So here to here. So I'm going to start trusting that you could do this. This is really 15 over 1. Let me just write it there. 15 over 1. Okay, now times, you could write it like this. X over 3. So what would this give you? This would give you 15x over 3. And then these reduce. So 3 goes into 15 5 times. So you'd have 5x there. So that first term, you're going to get 5x. Let me just do this next one like this. So I'm doing 15 over 1 times 3 over 5. This time I'm going to do it this way. I'm going to reduce. 5 goes into 5 once. 5 goes into 15 3 times. So you should just get 9 over 1, which is just 9. So you can do it either way. Multiply it out and get like 45 over 5, or you can just cancel or reduce those out. Either way, you should get 9 here. And now I'm not going to show these, but if you did this times this, you should just get x. And if you do this times this, you should get plus 5. So now we're back to an equation, no fractions, but we have our variable on both sides. So we're going to follow the techniques from the previous section. We're going to subtract x here, subtract x here. We're going to get 4x plus 9 equals the x's went away, 5. Now we want to get that 9 by itself, or sorry, the 4x by itself, so I subtract 9, subtract 9. We get 4x, because the 9's went away, equals negative 4. 5 take away 9 is negative 4. And last step is to divide both sides by 4. That way we just get x equals, and then negative 4 over positive 4 is just negative 1. There we go. All right, here's one for you to try. Okay, so a little tricky here. Notice this, you have a couple of numbers here that aren't fractions, but remember, one is 1 over 1, and 2 is 2 over 1. So the only denominators we have are 1, 2, and 4, all right? And so I could list out the multiples, 1, 2, 3, 4, 5, 2, 4, 6, 8, 4, 8, 12. So looks like the common denominator I have here, the least one is the number 4. So I will multiply both sides by 4. So I'm going to go 4 times the left side. 2 terms, so I need parentheses. 4 times the right side. 2 terms, so I need parentheses. And now I distribute. So I'm not going to show this step, but this times this should give you y. This times this should give you minus 4. This times this should give you 8. And this times this, when you do that, you should get negative 2y. Now we're back to an equation. We've got our variable on both sides, right, here and here. So let me add 2y to both sides to get it to go away on the right. And we should get 3y minus 4 equals 8, because the y's went away. We will add 4 to both sides to isolate that 3y by itself. 3y equals 12. And then finally we will divide both sides by 3. to get y by itself, and 12 divided by 3 is 4. Okay, excuse me, I'm bad allergies today. Okay, so this last little piece is just identify whether or not we have an equation or an expression, just to be careful for us to not forget. When you look at this right here, this is an equation because it has an equal sign and the variable there. So we'd be solving here for x. This is an expression. There's no equal sign. So let's see the difference between these two. If we were to do this first problem, what we would do is we would notice we've got fractions. So we'd list out 3 and 6. List the multiples, 3, 6, 9, 6, 12, 18. The smallest one we have here is 6. So what we would do is we'd multiply the left side by 6. There's only one term, so I don't need parentheses. Multiply the right side by 6. The right side would just become 1. And then this, I don't know why I wrote this upside down, I'm sorry. 5 over 3, not 3 over 5. So if you multiply this, this would be, remember that's 6 over 1, so that'd be 30 over 3, that's going to give you 10x. And then you just divide both sides by 10, and you get x is 1/10 when those x's go away. So we have a solution to that one. Now over here, this is an expression, so all we're being asked to do is just subtract these. Well, when you subtract two fractions, you have to get a common denominator first. So we look at these two denominators, 3 and 6, and the common denominator is 6. So what we have to do is we have to take our first fraction, 5/3. We have to multiply it by, we have to turn the bottom into a 6. So I have to multiply by 2 over 2, and then I still have the minus 1/6. So notice we're not doing anything on both sides of the equation because there is no equation here. So you have to turn the denominators into the same thing by multiplying by this really tricky little 1. And we did this a while back. It's been a while though. So we multiply here, this is going to be 10 over 6, and then we still have minus 1/6. So we're saying that this original thing is equal to this, which is now equal to this. And now that we have the same denominators, we know our answer is just the denominator, and then we just subtract 10, take away 1, gives us 9. And then what we can do here is reduce the fraction. 3 goes into the top 3 times, 3 goes in the bottom twice. So notice the difference between these two. The first one we said, hey, here's an equation. What value of x do I need to make this true? We said, oh, well, if x is 1/10, that'll be true. This is just like asking you, like, what's 2 plus 2? This is asking you to calculate this expression. We said this is actually equal to 3/2. So there's not a solution here, like we're not solving for, there's a solution, but we're not solving for x. Okay, these last two, I think I'm going to just leave these last two for you to see if you can get those on your own. This first one here is an expression, so you need to get all your denominators to be the same. This is an equation, so now you need to find the LCD and multiply it on both sides of the equation. See what you get. That'll do it for this section.